We're here at the Royal Society to try and explain to the public and to school groups how we use our attosecond laser system to try and freeze frame the motion of electrons orbiting atoms or charge moving in molecules. One of the messages we're trying to get across is you really need to freeze a really quick motion to understand what's happening, and when you do that you see something interesting or something new. So what we've got sort of on display here is a high-speed camera that freezes motions of just a water balloon popping.
We have a commercial camera running that's about as fast as you can buy. So it runs at 750 frames a second, and that means that you can have a kid with a water balloon in their hand, and you can pop the balloon and you can see the balloon fall away and the water sits there, and then the water starts to spray off. And it's a very nice demonstration that if you just watch something with your eye, you miss an awful lot of information that's sitting in there. And then we can explain to the kids that actually, as far as we're concerned, 750 frames a second is really, really slow. So our lasers run 1 billion times quicker than that. So that's just about fast enough to start looking at electrons moving in atoms. So our science is not about water balloons, it's about electrons. It's a cool way for them to learn that lots of things happen very quickly when normally you can't see them. We're only just at the stage where our laser pulses are fast enough to start looking at electrons. So this is a really new area. But electrons moving in atoms is one of the things that bonds big molecules together. So if you can watch how they move, you can learn how to control how they move. And that means you can make molecules fall apart in a way that you want them to, rather than in the way that they want to. And you can control the way that electrons move. And eventually that will have applications for sort of drug synthesis and fast electronics.
It's a really great opportunity to kind of give sort of students, particularly this kind of formative age, sort of typically around 16 when they're doing their GCSEs, the opportunity to meet scientists. Because one thing is, a lot of them will have heard some of the science before, but I would say that it's quite a unique opportunity for them to actually meet scientists, because their science will have been taught by teachers, and some of them will be scientists or have been scientists in a previous kind of career. But for many, and talking to them, this is their first chance to actually meet scientists, and I think it's quite nice for them to see that we're just sort of normal people, regular people, and sometimes our stuff doesn't work, and sometimes we get tongue-tied, and so that chance to actually see working scientists and to sort of realise that maybe this is something that they could do, because perhaps they have this image of the boffin with the white coat and stuff, and maybe that doesn't appeal. I mean, for young kids, it's not a particularly cool image. So perhaps we're sort of breaking that barrier down a little bit and sort of saying, it's regular people doing science. But obviously, on the scientific level, what we're hoping is that they'll leave with a few kind of key take-home messages, which is that the importance of this kind of work for developing kind of new technologies in the future. I mean, the kind of research that we're showing them today, or illustrating to them, is really probably going to be the basis of kind of the consumer goods that they might be using in 10 or 15 years' time, in terms of faster electronics, for the next generation of iPods and phones and stuff, better drugs, designer materials, all of these kind of applications we can see spinning out of this kind of research, maybe on the timescale of 10 or 15 years.